Hey everyone, welcome to Models and Agents episode 35. It's April 25th, 2026, your daily briefing on the AI models and agents that are changing everything. And no, not those kinds of models and agents. Let's get into it. Google DeepMind's Vision Banana shows image generation pre-training may be the true foundation model path for computer vision, beating SAM3 on segmentation and Depth Anything V3 on metric depth. What you need to know today is that DeepMind argues convincingly that generative pre-training for images delivers the same leap for vision that GPT-style pre-training delivered for language. The benchmark results back this up in impressive fashion. At the same time, the local LLM community keeps getting more excited about sparse models that punch well above their weight on agentic coding, and we have fresh prompting guidance for GPT 5.5 that basically says forget everything you knew about previous versions and start fresh. This week, pay attention to the accelerating quality of sparse and MOE local models alongside fresh guidance on how to actually extract performance from the latest frontier releases. The top story is Google DeepMind introducing Vision Banana. It is an instruction-tuned image generator whose pre-training approach they position as the vision equivalent of GPT-style language pre-training. The model reportedly outperforms SAM3 on segmentation tasks. It also beats Depth Anything V3 on metric depth estimation. What makes this significant is the suggestion that scaling generative objectives on images yields more transferable representations than traditional supervised vision pipelines. This reframes computer vision foundation models around generation rather than pure discriminative training. It potentially unifies image understanding and creation under one pre-training paradigm. For developers working on segmentation, depth estimation, or multimodal agents, this is immediately relevant. You can now experiment with a single generative backbone that appears stronger on core geometric tasks than specialized models built for those exact purposes. Keep watching for follow-up releases that integrate this approach into agentic vision workflows. Open-weight variants would let the community stress test the claims at real scale. Moving to model updates, the sparse Qwen 3.6 to 35BA3B continues to impress. One community tester used it to port a non-trivial C++ audio synthesis library called Odd Voices over to Rust. It took roughly 5 hours across 2 nights. The resulting code produced output that sounds virtually identical to the original despite some minor speed and edge case bugs. The model showed strong self-correction, referencing the source implementation when asked, and updating its own code accordingly. That level of behavior used to be associated mainly with much larger cloud models. Users report it outperforms Gemma 4 on agentic coding tasks while running several times faster thanks to its sparsity. This continues the encouraging trend of highly capable local models, closing the gap with proprietary APIs for software engineering workloads. DeepSeek also dropped both base and instruct versions of its newest models. We are talking about the V4 Pro at 1.6 trillion total parameters with 49 billion activated, plus the smaller flash version. These are now runnable on Huawei Ascend hardware. While no longer the outright benchmark leader, the release shows DeepSeek's continued commitment to open weights, base models, and detailed research papers. Many other labs have been pulling back from that level of openness. The models target practical inference on non-NVIDIA silicon. That expands accessible high-parameter options for practitioners running on Ascend clusters or looking for alternatives to closed ecosystems. The instruct variants are worth evaluating for coding and reasoning tasks. Another interesting result from the local community involves KV cache quantization on Qwen 3.6 to 27B. Perplexity testing at 200,000 contexts showed remarkably small degradation. The Q40 quantization added only 0.0148 perplexity versus the F16 baseline. Even the aggressive Turbo 3 3-bit version added just 0.0888. That is still considered safe for many programming workloads. The model's density above 20 billion parameters seems to make it unusually robust to aggressive KV cache compression. Some commenters caution that perplexity alone can understate impact on math-heavy benchmarks like AIME. Still, if you run dense 27 billion class models on limited VRAM, these Q4 or Turbo 3 KV cache settings are now worth testing aggressively. On the GPT 5.5 front, OpenAI released detailed prompting guidance alongside API availability. The core recommendation is to treat it as an entirely new model family. Start prompt tuning from the smallest viable prompt rather than porting legacy stacks from earlier versions. For long-running agentic tasks, they suggest emitting a short user-visible progress message before tool calls. This improves perceived responsiveness. The guide also includes migration advice for code bases that use their Codex agent. Now let us talk about agent and tool developments that actually matter for builders. GitNexus has gained serious traction with over 19,000 GitHub stars. It is an open-source MCP native knowledge graph engine created by Abhigyan Patwari. The tool directly addresses a core failure mode of coding agents, which is editing code they do not truly understand. By building a live structural graph of the repository, it supplies agents with explicit awareness of dependencies, call graphs, and architectural intent. Both Claude Code and Cursor users can integrate it today. This should meaningfully reduce hallucinated refactors and improve large-scale changes. There is also a new fully local implementation that combines Hermes Agent, the recently praised Qwen 3.6 to 35 BA3B and 4-bit, and Kua driver. It delivers multi-cursor and background computer control that feels surprisingly close to frontier agentic capabilities. The project demonstrates that current open models plus lightweight drivers can already approximate what used to require cloud dependencies. Builders experimenting with local agents should examine this stack for self-hosted automation or coding workflows. On the practical and community side, there is a really useful open-source 9-task benchmark for coding agent retrieval augmentation. The Paper Lantern Challenges repo contains fully reproducible prompts, agent code paths, and evaluation scripts. It covers practical software tasks including test generation, text-to-SQL, PDF and contract extraction, PR review, classification, routing, and summarization. When they added a retrieval tool over recent computer science literature, the performance deltas ranged from 0.010 to 0.320. The largest gains came on extraction and test generation tasks that benefited from 2025 and 2026 techniques unknown to the base models. Every prediction file and the approach documentation is public. This makes it an excellent test harness for anyone building RAG-enhanced coding agents. Microsoft has published a collab-ready tutorial on open mementos. It walks through streaming the dataset, parsing its block and memento token format, measuring compression ratios across domains, and preparing reasoning traces for fine-tuning. The memento representation offers substantial context compression while preserving structured reasoning summaries. Fine-tuning practitioners working on long-horizon agent memory or chain-of-thought distillation should run the notebook. It will help you understand the format before building your own datasets. Simon Willison also shipped version 0.31 of his popular LLM command line tool. It adds direct support for the new GPT 5.5 model. You now get a verbosity option set to low, medium, or high for GPT-5 and later models. There are also image detail controls ranging from low to high, auto, or original. Extra open AI models defined in YAML are now registered for async use as well. If you already use LLM for local experimentation or rapid prototyping, upgrading gives immediate access to these finer controls. Okay, let us pop the hood on how these sparse architectures actually work at scale, because the gap between marketing claims and engineering reality is worth understanding. Everyone talks about router networks as if they magically pick the best expert every time once you have enough total parameters. In practice, the router is a tiny neural network trained jointly with the rest of the model. It uses the main loss plus an auxiliary load balancing loss that prevents the system from collapsing to just a few dominant experts. Without that auxiliary term, routers tend to converge on a handful of favorites, leaving most capacity idle. The auxiliary loss penalizes uneven token-to-expert assignment across each batch, usually measured by the coefficient of variation of expert load. Modern setups add noise or stochastic routing during training, then switch to deterministic top-K selection at inference time. At the scale of a 1.6 trillion parameter model with only 49 billion activated, the real costs come from expert parallelism, all-to-all communication patterns, and careful placement of experts across accelerators. The heavily compressed attention techniques mentioned in recent releases are often a direct response to the memory wall created by storing full key-value states for million token contexts across dozens of experts. These systems trade exact attention for approximate retrieval plus heavy quantization just to keep activation memory manageable. The trade-offs are real. Stronger load balancing can slightly hurt final loss because it forces the model to use suboptimal experts on some tokens. Aggressive compression of attention states can degrade needle-in-haystack retrieval once context grows beyond a few 100,000 tokens. The quality advantage of these architectures tends to be largest in the 30 to 200 billion active parameter regime. Beyond that, the returns diminish and communication overhead can start to dominate. So, when should you actually reach for one of these versus a dense model of similar activated size? Prefer the sparse route if your workload has high variance in token difficulty, such as coding, math, or multilingual text, and you have infrastructure that can handle the all-to-all traffic. The gotcha that bites most teams is treating the router as an afterthought during fine-tuning. Without retuning the auxiliary loss and possibly reintroducing noise, the specialization learned in pre-training collapses, and you lose the speed and quality advantage you paid for. If you have not tried the Qwen 3.6 to 35 BA3B in Q4 or Q5 quantization inside Klein plus VS Codium for local agentic coding, this week is a great time. The self-correction and codebase exploration quality is reportedly closer to recent cloud models than previous local attempts. Integrate Git Nexus into your Claude code or Cursor workflow if you routinely see agents edit files without understanding surrounding architecture. That 19,000 star knowledge graph gives immediate structural awareness. Run the Paper Lantern Challenge's benchmark suite against your own RAG coding agent to quantify exactly how much retrieval over recent literature improves extraction, test generation, and review tasks. Upgrade to LLM 0.31 and test the new verbosity and image detail controls with GPT 5.5. Following the guidance to start prompt tuning from a fresh minimal baseline is worth doing before you port old stacks. Experiment with Turbo 3 or Q4 KV cache on Qwen 3.6 to 27B at 128,000 to 200,000 context if you are VRM constrained. The perplexity numbers suggest you may be able to run larger effective contexts than common wisdom allows. On the horizon, Noose Research is hosting an AMA on Wednesday, April 29th, focusing on Hermes Agent with deeper discussion on open-source agent orchestration and memory techniques. We should also see continued releases in the DeepSeek Vive 4 family, including potential smaller variants or further Ascend-specific optimizations. The ecosystem around MCP native tools is growing as more coding environments adopt structured knowledge graphs and context protocols. Expect further guidance and fine-tuning recipes for GPT 5.5 as developers migrate production agents and discover which prompting patterns no longer transfer from earlier versions. Before we go, tomorrow keep an eye on deeper community exploration of how these new sparse coding agents handle complex multi-file refactors in real projects. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.